little bit of numberage here. Math people like to make things almost as hard as humanly possible. So let's write this down. Numbers. Numbers, numbers, numbers. Here is how we categorize them. Categorize. Okay. Some of these we won't talk about at all. Some of these you don't talk about till you get to high school. Okay. We've got, first of all, we've got, the ones we're going to talk about are the real numbers. How about that? Is that not a good thing? And I'm going to make a box that stands for all the real numbers. Okay. Let me test your 7th grade minds and see if we've actually come up with something here in the real world here. If there's such a thing as real numbers, that means there are probably what other type of numbers? Peter, fake numbers. But we don't really, it's, well, I don't know if I like the word fake. We don't really use the word fake, but we call them, if all of your friends are not real, and you talk to this person, he is imaginary, yes. We have a whole list of numbers that are imaginary. Oh, is it ERY or ARY? Everybody? Does that look right? Here, just put a little thing there that's either B or A, we don't care. Okay. We are not, well, we do actually talk, well, we don't talk about imaginary numbers, but there's a category over there. It's just over there. We'll just call it that. Okay, real numbers are all the numbers that you deal with. And the real numbers get broken down into 2 different categories. We're going to draw 2 different boxes here. I'm going to make a big one because there's a big one and a small one here. Real numbers either come in what we call, you'll like this I think, rational numbers. Here's my box for rational numbers. And if there is a box of rational numbers, guess what? There's a box. Oh, look at you guys. Irrational numbers. By the way, the word irrational means what? If something's irrational, what's it mean? If you start talking to me and I go, you are completely irrational, Kelsey, it means
Crazy.
Crazy, or another way is it doesn't make sense. Makes no sense. Now, let me tell you the numbers that don't make sense to us. The numbers that don't make sense to us are, there's really only 2 things you have to remember. They are the square roots that don't work out. Square roots that don't work. For example, an example of that would be the square root of 2. There is no perfect exact answer to the square root of 2. If you take a calculator and you put in the square root of 2, it will spit out a whole long list of decimal numbers, and those decimal numbers will never stop. They stop on a calculator because you can only go so many ways. Okay. I should probably do that. Do I have a calculator on here? Sure I do. How about here under tools? Calculator, where are you at? Anybody? More tools. Calculator. If I take the square root of 2, and I hit first square root there, it gives me 1.4142135623733095, and it only stops there because that's all the digits that this screen will display. This number would go on forever and ever and ever. The other thing that goes on forever is pi. So when it comes to irrational numbers, you just have to think of the square roots that don't work out and pi. Now what other square roots don't work out? Square root of 5 doesn't work out. Whatever ones, the square root of 9 works out because 3 times 3 is 9, right? Square root of 16 works out because 4 times 4. But any of those other square roots that don't work out, the square root of 8 The square root of 8 is irrational, and I would get the same thing. Where'd my calculator go? If I take the square root of 8 and put it in here, see it goes all the way over there. And that probably rounded before. But if I do the square root of 16, it works out nicely. Square root of 16 doesn't fit in this category because it works out. It makes sense. All these other ones, because they're decimals that never work out, they don't make sense. Okay, because you can't think of it. So those are all the irrational numbers. Now in the rational numbers, that's all the ones that do make sense. Okay, and in the rational numbers we have fractions and decimals and all sorts of other things. Those are the ones that are strictly only rational, because in the rational we have some subcategories. In the rational numbers we have smaller categories, and the first one is integers. Now when I was your age and you asked me what an integer is, I wouldn't have been able to tell you. But you probably can. What is an integer? Does anybody know? Anybody know what an integer is? If I ask you what an integer is, Nicholas?
Numbers that are above 0, or is it 0 and above that are whole numbers?
Nah, you're thinking of the whole numbers. Or the counting numbers. Integers are
Negative.
and both negative and positive whole numbers. Negative and positive whole numbers. Okay, in other words, you could have negative 15, you could have 10, you could have 6. Those are all integers. You can't have fractions or decimals. Those are not integers, but they are rational. They make sense, but they're not integers. And then under the integers, we're getting kind of small here. I have another color here. Under the integers, we have what are the whole numbers. Under the integers are the whole numbers. Whole numbers, I'll just tell you, whole numbers are the same as integers except there's no negatives. Okay, so they are the positive numbers, and they start with 0. So it goes 0, 1, 2, 3, forever that way. And then the very smallest group of numbers we talk about are the, everybody running out of room?
Yeah. Yes.
Are the counting / natural numbers. The counting / natural numbers. And those children, the best way to remember this is when your parents taught you how to count. What did they say? Yep, exactly. They said, okay, here we go, let's count with your fingers. 1, 2. The natural and the counting numbers are exactly the same as the whole numbers, except your parents, when they taught you to count, never said to start with the number 0. 0 is not a natural or a counting number. Okay? In some sense, if you think about it, our concept of 0 is a pretty tough thing to understand. Okay, how do you teach a baby that there's 0 there? Or nothing? How would you hold your fingers up to show 0? Yeah, you go like this and they go, yeah, you're just showing the symbol we use for 0. Okay, now, since you all wrote that down and you ran out of room, would it be better if I just gave you a sheet that had that on it?
Yes.
Why did you make us write that down? Somebody can answer that. I think it's better sometimes if you write it down. Take a look. By the way, this is only for real numbers. In case you want something a little bit crisper. Yes, sir?
So when you use for this?
Okay.
Okay.
By the way, since I'm giving this and I can tell you're all mesmerized by all this, I'll tell you what an imaginary number is. Anybody know what an imaginary number is? Google Slides.
Exactly. It's not real.
Let me throw this at you and see if you can come up with this here. What is the square root of 36? What number times what gives you 36? What is the square root of 100? 10. What is the square root of a negative 4? Well, if you take a negative 2 and multiply it by another negative 2, guess what you get? You get a positive number. Okay? There is no way to ever get a negative under a square root sign. But when you get to upper level math, they actually do it. And these are the imaginary numbers. Because there's no really such thing, but when you get to upper level math, you actually do get that. Now, looking at your sheet here, let's talk about something because you need to kind of be able to understand this a little bit here. If I asked you, if I gave you the number -2, and I said, what groups or sets of numbers, of these numbers we talked about, does -2 belong to? Well, if I think about -2, is -2 a counting number? No, because counting numbers start at 1. Is not -2 a whole number? No, because whole numbers start at 0. Is -2 an integer?
Yes.
Yes, so it is, well, usually when we tell what set it belongs to, we say it is an integer. This little brace sign means it belongs to that set. It's an integer. It is also a rational number because it's a member of everything above it. And it is also a real number. And that's hopefully what you can see from the sheet. If a number falls inside one of these, it also falls inside all the other boxes that surround it. Okay, Al?
How do you know if it's not imaginary?
Because the only it has to be a square root. First thing you look for, if it's a square root of a negative, that's imaginary. But none of those, you won't run across any of that sort of stuff there. What about the decimal 0.8? What sets of numbers does 0.8 belong to? Well, it's not a counting number, it's not a whole number, it's not an integer because they have to be whole numbers. There's no fractions that are integers. It has to be, Peter,
Rational and real.
like it's a rational number and it's a real number. Okay. If I gave you the number 0, 0 belongs to Jacob.
Whole numbers,
It's a whole number.
integers,
It's an integer.
real numbers.
It's rational too and real. Remember, every box that it's inside is what it belongs to. Okay. What about? Well, let's go one more. -1/5. -1/5. Even though I don't have them up there. Kelsey?
Rational,
And?
integer,
Nope. Integers are whole numbers. Rational and? Sam?
real, irrational.
No, it's not irrational. Irrationals are only pi and square roots. Not imaginary either, that's square roots. This is not a square root. It belongs to rational and real, the big box. It's probably a big box there. The big box. How about one more? What about the square root of 15? The square root of 15. Calvin G's on.
Imaginary?
Nope. Square imaginary ones are only negative square roots.
Irrational,
It is irrational and it is also
real.
real. Irrational and real. To which I must say, somewhere in these I got some I need to pull them back. What's been the best thing about the day so far?
This class.
Oh, yeah, that's it, Jacob. Jacob. Hold on a second, let me stop this crazy thing.